Hello class, welcome to another lesson. Today's learning goal is I can rewrite a number into scientific notation. So let's get started. So here we have 90,000 times 1,000, okay, right here. And here, this results in 90 million, okay? Because we got 1, 2, 3, 4 zeros here and 3 zeros here, so together there should be 7 zeros, which there are right here. Okay. If we wanted to divide the first factor by 10, the first factor is this 90,000 right here. Okay. In order to get 90 million still as our product, we would have to multiply the second factor by 10. That means multiplying this by 10 in order to still get this 90,000. So here we show that we got 90,000 divided by 10, which gets us 9,000, and 1,000 times 10 to get us 10,000. And the reason that still gets us 90 million is because we just switched around where the zeros were. So here there's 3 zeros, and here there's 4 zeros, so at the end we'll still have 9 zeros at the end. Okay? So while we change the look of the number from this right here, 90,000 times 1,000 to 9,000 times 10,000, the product is still the same, 90,000. Okay? So all we did was really divide this by 10 and multiply this factor, the second one, by 10. Okay? And in the end, these two parts, if we divide something by 10 and then multiply something by 10, we are going to get the same thing because they cancel each other out. Okay? We just changed the look of it, but the value of it is still the same. Okay. Same thing over here. We have 9,000 times 100. And that's going to get us 1, 2, 3, 4, 5 zeros, so 800,000 right here. If we wanted to multiply the first factor by 10, in order to get 800,000 as our product still, we would have to divide the second factor by 10. So we show that right here. So if we want to multiply this first factor by 10 to get 80,000, to still get the 800,000 that we want, we'd have to divide the second factor by 10. Okay? So here we just multiply this one by 10, multiply by 10, and in order to get still 800,000, we have to divide this one by 10. And again, all we did was switch around where the zeros are. This one now has 4, when it originally had 3, and this has 1 when it originally had 2. At the end, there's still 5 zeros, so it's still going to be 800,000. Okay, so that's the basis of what we're going to be doing today, except we're going to be doing an exponential notation, or it's things that look like exponential notation. So for example, 90,000 times 10 to the third kind of looks like it's an exponential notation. However, it is not. Okay, this is too big. This coefficient is too big. It's too big because of these 4 zeros. So we're going to divide this coefficient by 10 to the 4th power. Okay, and what that does is it's going to make us move this decimal back 4 times. 1, 2, 3, 4, and puts the decimal right here. So we have 9 as our coefficient, which is perfectly allowable. Now when we do that, this changes the value of the entire thing unless we multiply the base 10 by the same thing. Multiply it by 10 to the 4th. So now we have 10 to the 3rd times 10 to the 4th, which gives us times 10 to the 7th. So notice how we're just essentially splitting the number into two parts, the coefficient and the base 10. Okay, and then as a result, this right here is going to have the same value as this number up here, because all we did was multiply by 10, or divide by 10 to the 4th, and then multiply by 10 to the 4th, so those cancel each other out. But now it just looks different, but has the same value. Okay. Again, this is actually the example that was previously given up here. Okay. Notice how the same thing, because 10 to the 3rd is the same thing as 1,000, right? And so this should get us 90 million. And if we were to write this out in expanded form, we have 7 zeros, so 1, 2, 3, 4, 5, 6, 7. Not expanded form, excuse me, in numeric form. okay, it's going to get us the same thing. Okay, so let's try another one. We're going to rewrite this one in scientific notation. Okay, the coefficient right now is too big by 3 zeros, so we're going to divide it by 10 to the third, because we want to move the decimal place back 1, 2, 3 to put it right here. Okay, that gets us 8 down here, but in order to keep the same value, we have to multiply the base 10 part by 10 to the third, and to the second times 10 to the third is 10 to the fifth. And now this is in scientific notation. Conversely, we can still do this with negative exponents. Okay? So here, this is too big. We want to move the decimal place over one time to make our coefficient smaller. So since we're making a coefficient smaller, we're going to divide by 10, move it one decimal place back. As a result, we need to multiply our base 10 by 10, or 10 to the 1, okay, which means we get 7.452, which is now a legal coefficient for scientific notation, times 1 plus negative 6 is 10 to the negative fifth. Okay. So here, go ahead and try this one out on your own. Here we want to move the decimal place backwards 3, making our number smaller, so we're going to divide by 10 to the third because we're making it smaller. 10 to the third, 1, 2, 3, put our decimal place right there, so we get 8.24232. Since we're dividing by 10 to the thirds, we need to multiply this one by 10 to the third, getting us 10 to the 7th times 10 to the third, we add the exponents, times 10 to the 10th power. Now, for the next one, here we actually want to go the other way. We want to make our coefficient bigger. Okay? We need to make it bigger by moving the decimal place over 1, 2, 3. Okay? In order to make something bigger, we need to multiply this one now. Multiply it by 10 to the third. So we've multiplied this by 10 to the third now. Okay, which means, however, that since we multiplied this part and made it bigger, we need to make our base 10 smaller, which means we're going to divide by 10 to the third. Okay, as a result, what we get is 8.32 times, we divide by 10 to the third, we subtract the coefficients, 10 to the second. 5 minus 3 is 2. Okay. So here again, we have a number for our coefficient that's too small. So here we're going to multiply again to make it bigger. We're multiplying it by 10 to the second because we want to move the decimal place over twice. If we're going to multiply by 10 to the second, we got to divide the other part by 10 to the second. Okay. So if you multiply one part by something, you have to divide the other part by something. If you divide one part by something, you have to multiply the other part by the same thing. So we're going to divide by 10 to the second. So again, this is going to be 2.42. When we're dividing again, we subtract, so negative 2 minus 2. That gives us times 10 to the negative fourth. Go ahead and try the first 3 practices on your own. So in the first one, our coefficient is too small, so we're going to multiply it by 10 to the second in order to move the decimal place over twice, which gives us 9.24, which means we have to divide our base 10 by 10 to the second, the same number as we multiplied in the coefficient by. And so since we're dividing by 2, we're going to do negative 18 minus 2, which gets us negative 20 over here. Number 8, our coefficient is too big, so this one we have to divide. Okay, divide by 10 to the third in order to move the decimal place 1, 2, 3 spaces over because we need to make our coefficient smaller. We're dividing, which results in 3.8241. If we're dividing by 10 to the third, we need to multiply our base 10 by 10 to the third, which gets us negative 2 plus 3, which gets us 10 to the 1. Over here, we have a coefficient that's too big, so we're going to divide it by 10 to move it one decimal place over, getting us 4.9. As a result, we need to multiply our base 10 by 10 to the 1, which gets us negative 7 plus 1 is negative 6, so 4.9 times 10 to the negative 6. Try the last three out on your own. So, in number 10, our coefficient is too small, so we need to multiply it by 10 to the 4th, getting us 4. We need to divide, as a result, our base 10 by 10 to the 4th, which means 10 minus 4, because we're dividing, is 10 to the 6th. Over here we have a coefficient, again, too small, so we're going to multiply this by 10 to the 3rd to move the decimal place over 1, 2, 3 times to get us 5.82. Since we're multiplying by 10 to the 3rd, we have to divide by 10 to the 3rd on the other factor. Well, the 10 to the negative 8, we're going to divide by 10 to the 3rd, which means we're going to subtract. Negative 8 minus 3 is 10 to the negative 11th. And in the final one, we have 32.4, which means it's too big. We got to divide by 10 to move the decimal place over once. 3.24, which means we need to multiply this by 10, which gets us 10 to the 20th.